H2, redox test. Let's do it. First thing we got to do, we have a combustion reaction here. This is sugar, glucose with oxygen, creating carbon dioxide and water. That's what we're doing right now as we're metabolizing sugar. We need to breathe in oxygen, and we give off carbon dioxide and water. That's what we do. When we breathe, if you want to see if you're alive, put a mirror on your breath, and if you see little water droplets, that means you're alive. If you're not doing this reaction, you're dead. Of course, you wouldn't be able to tell that, but yeah, oh well. Your friends will know if you're alive or dead. How about that? So let's balance this thing first. Let's do carbons, hydrogens, and oxygens last, as always. Carbons, 6 carbons. How many CO2s do we need? That's right, 6. Okay, good. Let's do hydrogens next. 12 hydrogens. So how many hydrogens do we need here? Well, we're going to need 6 H2Os to give us 12 hydrogens. 6 times 2. So carbons are balanced. Now hydrogens are balanced. Now all we need are the dreaded oxygens. Let's see here. 6 times 2, that's 12 oxygens. And then 6 times 1 is 6 oxygens. Oops, let's get these markers rolling. Okay, good. Over here we have 6 oxygens. So we need a total of how many oxygens to make this thing balanced? We need a total of 12 more. And how many O2s to give us a total of 12 oxygen atoms? That's right, 6. Okay, you got it. So now this is all balanced. Part 1 is done. Very nice. You can erase your D's. The next thing we're doing is we're checking oxidation numbers. Let's start with oxygen. Hydrogen is +1, and it says 12 of them. That's the total charge on is +12. Oxygen is always going to be -2, and it's times 6, so that's -12. We know that this whole molecule is uncharged, so it's not like -2 or +2 at the end. So we need to know that all of this has to equal to 0. +12 and -12 is already 0. So what does the oxidation of carbon have to be? 0. Because that is, it can't be anything. It can't be higher, it can't be lower. So there it is. That's kind of tricky. Oxygen, O2, any element by itself is the element 0. Okay? Now let's take a look over here. CO2. Oxygen is -2. Since there's times 2, that's -4. What does carbon have to be to balance it? +4. Very nice. Okay, you see how I'm circling the oxidation numbers and then doing all the math in the bottom? This is a nice way to stay, keep yourself from getting lost. All right. Over here, and communicate to your teacher what you're doing. So they can find it. They don't have to fish for it. Okay, oxygen over here, -2. Hydrogen is +1. Since there's 2 of them, that's +2. Hey, look, that balances out. Isn't that nice? All right. Now that you have the oxidation numbers, let's find out who is gaining electrons and who's losing electrons. So here we go. All right. So let's switch colors. Let's take a look at carbon here. Carbon starts at 0 and it goes to +4. So 0 to +4, it is less negative. It's losing electrons, and that is called oxidation. Right? What do? The line goes there. Loss of electrons is oxidation. Let's take a look at hydrogen. +1. The +1, there's nothing going on in terms of redox for hydrogen. Oxygen, -2, -2, -2. That oxygen is staying fine. But look at this one. 0 to -2, 0 to -2. It's becoming more negative, so it's gaining more negative electrons. So this guy here, and we'll do it twice, here, that is gaining electrons, reduction. Gaining electrons, reduction. Okay. So the story you can tell about this is that when these two are reacting, oxygen is playing tug-of-war with the electrons, and it's a tie. Over here, the oxygens and the hydrogens, and the carbons are like, okay, they're kind of happy. When you react it with oxygen, oxygen is bound to carbon. It takes the electrons pretty much from carbon. It's a partial transfer of electron because it's 2 nonmetals. Okay? So this is a partial transfer of electrons. Okay? This is a covalent compound. They're still sharing electrons. If you were to draw out the, what's going on here, here is the oxygen. Okay, they're sharing electrons, but, you know, oxygen is a lot more, is really holding on to those electrons a lot more. So it's sharing it, but it is not a complete transfer, but is a partial transfer. It's actually a lot better for oxygen before. Let me just erase this here. Before, oxygen used to be in a tug of war with its twin brother. Not so happy to do that. It's sharing electrons. It has to share. This one now can kind of hog them up with carbon. So it's losing, carbon is, in a sense, is losing electrons, although but not completely. So carbon is getting oxidized, oxygen is getting reduced. Same thing with H2O, the twin brothers oxygen, now they're bound to good old hydrogen. Hydrogen's pretty fine giving up those electrons. All right, hydrogen's pretty happy, see it's pulling the electrons, they're sharing electrons, but it has a more, it's more to himself than when it was stuck with its twin brother oxygen. Okay? But really the story is carbon is undergoing oxidation. This is the oxidizing agent. Oxygen is going into reduction. You can see because the numbers are increasing, and all of these are undergoing partially transfer of a partial transfer of electrons because they're both covalent compounds. Okay? That's the story. Once you figure out the numbers, then you can just tell the story of the oxidation and the reduction. Okay? This is kind of extra. You don't necessarily need this, but it's good to know where it comes from. All right, zinc iodide. We reacted zinc and iodine together. It got hot. Zinc was metal. Iodine was that brown liquid. The one that it was actually that solid stuff. When we lit on fire, it turned purple. In water, in acidified water, it turned that brown color. When we reacted them, remember we shook them, and then eventually all the iodine disappeared. So just a quick reminder. What's going on here is this is a straight up oxidation reaction. In the forward reaction, zinc is giving off its electrons to iodides. See, they're sharing here, but they would rather have the electrons to themselves, so that's kind of driving this reaction. Also, zinc is very stable when it gives off its electrons because it looks like a noble gas, it has noble gas configuration. So this is Zn, it loses 2 electrons, so it becomes Zn2+. Each of these iodines here become, let's just draw its normal electrons. They're taking these electrons from zinc, and they are negative. So these are 2 negative ions of iodine, okay? So they are negative here. So this gives us electrons here. This is when you lose electrons. This is loss of electrons, oxidation. And then iodine is gaining electrons. It's undergoing reduction, okay? So here they are. And this is zinc iodine. You can think of it in terms of Zn(I2) aqueous, because when you get rid of the in water, they're all kind of dissolved. When you get rid of the water, remember we burnt the test tube and we evaporated the water, and they came together to form a white solid, which is zinc iodide, Zn(I2). It is a metal and a non-metal. And so, once again, if you were to think of in terms of redox, you can actually see the complete transfer of electrons. The zinc gives them totally to iodine to make total ions, a negative ion and a positive ion. Versus these guys up here, which are still sharing. You don't see the ions in those things. Okay? How do we reverse this reaction? Well, remember this? A battery. A battery has 2 parts. Just like a voltaic cell, the naming is the same, negative and a positive. The negative is called the anode. Okay. And then over here is the cathode, positive. Okay. In the anode, you are giving off electrons. Electrons come off. In the cathode, electrons are coming in. Okay. And it all has to do with the chemical reaction that's going on in here. Over here, when you're losing electrons, that's oxidation. And over here, you're gaining electrons. Usually you connect it to like a light or something, or your electronic device, or like this phone that I'm using to record this video, and this circuit of energy drives a computer chip or gets your light bulb going, right? And we can use it to reverse reactions. So who's going to want electrons? The iodine negative or the Zn2+? That's right. Zn2+. Okay, so here it is. Here's the Zn2+. And how many electrons will it take? It's going to take 2 electrons. So we give it, we'll say that we give it 2 electrons, and it turns into Zn with 2 electrons. Isn't that the original metal we started out with? So this is zinc solid. So remember on the electrode when we put it in the solution, on one of them, on the anode side, you should see zinc metal starting to form. Now let's see what happens on the iodine side. Iodine here, we have these 2 iodines, they're negative. Alright, they're hanging out with borrowed electrons from zinc. Okay. And this side is like, you know what? I want these electrons. So it's taking, so it's minus, so we'll put plus 2 electrons here, minus 2 electrons. So it's taking these electrons away. Uh-oh. Are they going to be happy by themselves? No. You're going to get 2 iodine molecules. They were fine by themselves with the extra electron, but when they're not happy, they're still twin brothers. They love their twin. They're going to get back together and they're going to bond back into iodine. There it is. So you've recreated the covalent compound of iodine here. So this is I2. And if it's in solution, it would be aqueous. But you could also, if you evaporate off the solution, you can also have I2 solid if you let the water evaporate. So there it is. Once again, zinc gives its electrons to iodine. You create the zinc plus ion and iodine negative anions. Okay. This is a complete transfer of electrons. The battery in the anode, there's a loss of electrons here. And who's gaining electrons, actually? That's right. Zinc is undergoing reduction. Here's the oxidation, here's the reduction. Okay. Over here, so you give the electrons to zinc, you make zinc solid. Over here, the iodine anions, they give off the electrons. Now they have 7 electrons, valence electrons, they come together and they form the ionic compound. So if they're losing electrons, well, this gains, this is loss of electron oxidation. You see how oxidation is always coupled with gain, with reduction, oxidation, and reduction. Okay, that's it. And if you forgot about this, check your notes, because that's where they are. Remember the demo I did over there? All right. It looks like you missed that little side there. So check this out here. Here's the 2 negative anions. They come together. They bond to form iodine. Okay, cool. Technical difficulties.